So, what is scientific notation? Scientific notation is a way to think about numbers to kind of make them easier to deal with. So, they're either really big or really small. Those are usually the times we talk about scientific notation, although you could put any number into scientific notation that you want. So, really big or really small, it makes them easier to work with. So, in any number in scientific notation, there are two parts. The first part is what we call the coefficient. So you might be familiar in math when you have a number like 2x. The 2 is called the coefficient. Well, in scientific notation, the number before is called the coefficient. You need to make sure in scientific notation that that number is between 1 and almost 10. So you couldn't have a number like 15 times 10 to the fourth. That's not scientific notation. You also couldn't have 0.15 times 10 to the fourth. Because, again, in both of these cases, you have a number that's larger than 10 and less than 1. Your exponent is going to show you how many places you're going to move your decimal place to put it in the expanded or the standard form. And the direction, either right or left, is indicated by the negative or positive sign. So, for example, this is a really big number. I know that because of the sign of the exponent, which we'll talk about. That means we're going to move our decimal place 23 spots to the, in this case, right. And so that would be, let's see, 1, 2, and then 1, 2, okay, that is a lot of zeros. So you can see why you might want to put it in scientific notation. So like we just mentioned, the purpose of the exponent is to show how many places you're going to move your decimal point in order to write out the number in what we call the standard form. Okay? So if you have a positive exponent like we did on the other page, you have a number that is greater than 1. To write your number that is now in scientific notation into the standard form, you're going to move your decimal place to the right as many spots as the exponent tells you. So for example, 1.20 times 10 to the fourth. So I start where my decimal place is, and I go 1, 2, 3, 4. And I kind of think of it as like an egg carton. So I just put 2 zeros in there and then comma if you'd like. So 12,000. Now, I haven't told you the sig fig rule yet. So let me just say that sig figs are not correct for that number. But for the sake of example of scientific notation, that's the correct answer. For a negative exponent, you would have a number that is less than 1. And we're going to move our decimal place to the left this time to make it small. 1.40 times 10 to the third. So 1.40, this time we're going to move to the left. 1, 2, 3. Make that your new decimal place. Put zeros in there. So to make that nice and neat, it would be 0.00140. Now, do you need to put a leading 0 in the ones place? No. But I generally do, just because it shows intention, so that this decimal place is not just a stray drawing on the page. It's intended to be there, and that 0 indicates you have a 0 in the ones place. So now, if you have a number in scientific notation and you need to worry about sig figs, all of the digits in the coefficient of a number in scientific notation are significant, which means you don't have to put the number in the standard form in order to determine how many sig figs there are. So I intentionally gave you some pretty big exponents to show you that it's not important. So I am not going to move my decimal place 19 spots to the right. I already know my sig figs. 1, 2, 3, 4. How do I know that? Well, you know that a number has to be 1 or larger, and it's going to contain a decimal place, most likely. So you're going to have all your digits be significant. So those 3 sig figs, those 3 sig figs, and those 3 sig figs. Okay? And so now, I think I'm going to wait on that. All right, stay tuned. Next video.